Right. Permutations and combinations. Suppose 4 letters A, B, C, D are given. And you are asked to select any two. You are asked to select any two. Then you will think a while and start telling answers. Is it not? Very easy. What are the selections now? Then the selections are starting with A, we have AB, AC, AD. Now starting with B, we have BC, BD, and at last CD. So these are the selections. Since I said selections, your AB or BA both are same. Don't say, sir, BA or CA. When I say selection, whether those two letters are there or not is important, not their order. So order is not important in selection. Remember that. So I write, there are 6 selections. So for this question, how many is the answer? There are 6 selections. That is the answer. Here, for the selection, order is not important. A, B and BA, wherever you keep A, B, A came first, B next. Okay, that order is not important. Whether A and B, whether two letters I have selected or not is important. So for this selection, order is not important. For the selection, order is not important. That means if I take AB and BA, both are same. Both are same in selection. So no need to write AB and BA differently. It is enough if you write one. Right? Now, among these 6 selections, each selection, okay? Each selection is called a combination. So now onwards, when they say words like choose or select, okay, all these words come under combinations. So each of the selection is called a combination. So in our lesson, permutations and combinations, I defined combinations first with one simple example. I have given you 4 different letters, and a simple question is, out of given 4 different letters, in how many ways you can select 2 letters? So like this, you made selections. I wrote all possibilities. Nothing other than these. Only 6 possibilities are there. All these 6 are selections from the given 4 letters, alphabets. Okay, and each of the selection is called a combination. So in this question, I can ask like this also. If 4 different letters are given, the number of combinations of two things taken at a time from the given 4 is. So number of combinations means selection only from here. Okay. So keep in mind, selection is nothing but combination. Come on. Now this time, what I do is, suppose 4 letters A, B, C, D are given. Now you are asked to arrange any two. Arrange any two. In my previous case, I said order is not important. I selected A, B, A, C, A, D. No, I selected A, B, but I did not give order to A, B, whether A comes first or B comes first. That order I did not think of. But in the arrangement, order is important. When it comes to arrangement, order is important. So first, what I do, I select two letters. So first, select two letters. Okay. And then arrange each of the selection. Each of the selection. Now see, first I read selections. What are the selections from my previous solution? AB is one combination, AC, AD, BC, BD, CD. First select any two letters. I selected in these ways. And then arrange each of them. Now this can be arranged like this. I can write AB, BA. These are arrangements now. Okay. I write like this. AB, because this itself will give us AB, BA, and this will give us AC, CA. This will give us AD, DA, and here BC, okay, BC, CB, here BD, DB, and here CD is one arrangement and DC is another arrangement. So total how many arrangements? If you count 1, 2, 3, each selection is giving rise to 2 arrangements. Like that, how many selections are there? 6 selections are there. So 6 selections will give rise to 6 into 2, 12 arrangements. Right? I like the same thing. So each of the selection give rise to 2 arrangements. Each of the selection gives rise to 2 arrangements. So totally how many selections are there? 6 selections are there. Therefore 6 selections gives rise to 12 arrangements. Therefore 6 selections give rise to 12 arrangements. Now this is one arrangement. This is one arrangement. Like these 12 arrangements are there. Each of the arrangement is called a permutation. Okay. Each of the arrangement is called, this one is called a permutation. This one is called a permutation. Like that. Each and every arrangement is called a permutation. Each and every selection is called a combination. I hope you understood. Come on, write down. We have to understand the logic. Since only 4 letters are given and you are asked to take 2 at a time and arrange, it is possible to write all the arrangements. Think what happens when the number of letters are 10 or 20 like that, and you are asked to, out of those 10 or 20, you are asked to arrange 5 or 6 like that. Is it easy to write all those selections or arrangements? No. But when that question comes, we should be in a position to think, and by using any logic, we have to say answer. At least how many are possible? That is important for permutations and combinations rather than what are the arrangements or what are the selections. How many ways, in how many types you can write selections or arrangements is important, right? So slowly we are going to understand how to obtain formulas for permutations and combinations, like for these type of problems, right? Now, this is about number of arrangements. Now, this each of the arrangement is called what I said, permutation I said. So let us write that each of the arrangement, each of the arrangement is called a permutation. Here we can observe one thing, whether the number of permutations is a greater number or number of combinations is a greater number. When you compare number of combinations and permutations, we got arrangements from selections only. Each selection gave rise to 2 arrangements in this case, in this problem. So number of arrangements depends on number of combinations. First you have to select, and from that selection you have to arrange. So definitely number of permutations is a bigger number. That thing you have to note. So I write a note here. You have to write a note here. Number of permutations is greater than number of combinations. Sometimes equal also. In which case equal, out of 4 letters, if I ask you to select one, okay, if I ask you to select only one. So combinations, what are the combinations? If I take A, B, C, D as different letters, and if I ask you to select only one, then your answer will be A, B, C, D. One combination is A, the other is B, the other is C, the other is D. At the same time, if I change the question and ask you how many permutations are possible by taking one at a time from given 4 means, again there is no chance of ordering the selection. No, only one element is there, only one object is there. So in this case, what is happening? Number of permutations and number of combinations are becoming equal. So that's why I write number of permutations are greater than or equal to number of combinations. But in general, in all the cases, I can write number of permutations is equal to number of permutations is equal to number of combinations into what we did, number of ways of arranging, otherwise number of ways of arrangements, number of arrangements from each combination, So your number of permutations is nothing but a multiple of number of combinations. Come on, note down. So this is about what is a permutation and combination. We have some technical logics in order to understand permutations and combinations well. So under that, fundamental principle comes. Fundamental principle of counting. In this, again, two fundamental principles are there. One is addition and the other is multiplication. So how to remember which fundamental principle is useful in what type of problems? Generally, in the question R plays an important role, R or R. Okay. Then we will add the number of cases. And in the given problem, if the meaning is in such a way that and comes, first work and second work should happen. First work and second work should happen. Then in that case, you have to multiply. You have to multiply. For example, there are 20 boys in a class and 10 girls in that class. A class teacher has to select one candidate to make a monitor to that class. So how many chances are there? Means what we are doing? Logically, 20 girls are there and 10 boys are there. In how many ways you can make a monitor from that class? Means you are adding 20 plus 10, 30. So which fundamental principle you have used here? Addition. In that question, nowhere they mentioned or. Logically, that meaning is coming. Is it not? I can select a monitor for that class either from boys or girls. That is the meaning, no? So whenever that meaning comes, or comes, we have to add the cases. Here the first case is, the first work is selecting a boy. Okay. In how many ways we can select a boy? 20 ways are there. We can select any boy from the given 20 boys. So 20 ways are there. And the second work is selecting a girl. How many girls are there? 10 girls are there. In how many ways we can select one girl from given 10 girls? 10 ways. So totally how many choices I have to make a mentor to that class? 30 chances are there. So 30 is the answer for this question. I used this fundamental principle. And in another example, suppose there are 4 trousers and 3 shirts. Okay. A person has to wear both in order to go outside. Okay. That is if a dress means wearing both trouser and shirt. In how many ways he can wear dress? Means in that case, what he has to do? He has to wear a trouser and a shirt. Is it not? Here the logic is working with and both works should be done one by one. Both work should be done. Both means and, here you are using and. So 4 trousers can be wear in 4 ways and 3 shirts can be wear in 3 ways. So 4 into 3, 12. So in this case, what we are doing? We are multiplying. So basing on the question, you have to use the fundamental counting principles. Whether to add or multiply, that question will decide. That question will make you do that problem. So we are making it clear as for what type of problems are these fundamental, what type of fundamental principle we have to use. Okay. Now I'm going to write that one only here. Right. First I write addition principle. whenever a logical meaning of or appears in the question, okay, whether directly or indirectly, if or meaning comes, then you have to use addition principle. What is addition principle? If an operation can be performed in m ways, all m must be different ways, m different ways, and another operation can be performed which is independent of first, which is independent of first. Independent of first means that does not depend on the first operation, okay, of first in n different ways, in n different ways, then either of the cases or either of the two operations can be performed in m plus n ways. This can be extended. This can be extended to a finite number of operations also, to a finite number of operations. Means not only two operations. If a work is done in m different ways and another work is done in n different ways, which is independent of first, and the third work is done in p different ways, then either of these works can be performed in means m plus n plus p, like that. So this can be extended to a finite number, not only three, any number of any different types of works. Okay, we can add. I explained this now. One example. Just now I explained this. There are 20 boys and 10 girls in a class. The class teacher selects a boy or a girl for monitor of the class. In how many ways a teacher make a selection? So this is a fundamental, this is based on fundamental addition principle. So what is the first work? I write number of ways of selecting a boy. This is your first operation. How many? 30, 20. Similarly, number of ways of selecting a girl. How many? 10. So by using fundamental counting principle. Here, what is the fundamental counting principle? Addition, is it not? So number of ways is equal to because here the logic selecting a boy or a girl, in the question itself he gave that a boy or a girl should be selected. So this logical operator indicates add. So add these two operations, 2 plus 10. So number of ways is 30. Come on, write. If you see this example, a man has 4 schools towards north and 3 schools towards east of his residence. So in how many ways he can join his ward in a school? So first operation. First, a man has 4 choices to send his ward to a school which is in north direction to his residence. So number of ways of doing first work is 4. Similarly, number of ways of doing second work, second school, towards east, 3 schools are there. So he can choose in 3 ways. He can join in any of the schools. Any of the schools means either east-sided schools or north-sided schools. Is it not? So number of ways of joining in north-sided schools is equal to 4, and number of ways of joining in east-sided schools is 3. So which fundamental principle is useful here? So logically, these 4 ways or these 3 ways, he can choose either these 4 schools or these 3 schools. So when or comes, we have to use addition principle. So by using fundamental counting principle, which fundamental counting principle we are using here? Addition again. Number of ways is equal to 4 plus 3, which is 7. Okay. One more example. Suppose I don't write any problem in words. Just I draw diagram and I'll ask you a question. Suppose A and B are 2 cities. A man has to travel from A to B. He can travel either by flight, he can travel, by train he can travel, by road he can travel. So there are 3 modes of transport for a person to travel from one city to other city. This is city A and this is city B. And again, there are 2 options for him to go by flight. Suppose he can go by flight by Indigo Airlines or Jet Airlines. Suppose. And by train, suppose he has 2 trains, say one is Shatavahana and the other is say other train Janmabhoomi. Randomly I'm writing, I don't know whether they both coincide or don't know. I'm writing these names, Shatavahana and Janmabhoomi. And on road, say by bus he can go, by car he can go, and or by bike also he can go. Now the question is, in how many ways that person can travel from A to B? In how many ways? In how many ways a person can travel from city A to B? Here also nowhere I used the logical operator or. I have given the description here. A person has to travel from A to B. There are 3 chances, 3 modes of transport, because both are cities, I said. By flight he can go, by train he can go, by road also he can go. And if he wants to go by flight, again there are 2 options, whether Indigo Nation or Indigo flight or Jet Air flight. And a train means he can go by Shatavahana or Janmabhoomi. And the other one is bus. By road means again 3 options are there. So totally how many ways he can travel means first work can be done in. This is the first work. If you take flight, How many options are there? 2 options. So this work can be done in 2 ways. 2 ways. Or, okay, or if he goes by train, if he selects this train route, how many options are there? Again, 2 options are there. 2 ways. If he goes by, or if he goes by road, if he want to go by road, through road, how many ways are there? 3 ways. So he can do the work either by this method, this way, or this way, or this way. So totally how many chances he have to go from city A to city B means you have to add on 2 plus 2 plus 3 by using fundamental counting principle. So 7 is the answer. Come on, take down. Multiplication. Fundamental counting principle multiplication. We have to multiply. Okay. And the logic operator will be AND here. We have to multiply and the logic operator is AND. If an operation can be performed in m different ways, second operation can be performed in n different ways, then the two operations in succession, one after other, can be performed in mn ways. We have to multiply. And this can be extended to here also. This can be extended to finite number of operations. Finite number of operations. Not only 2 works. Here I wrote one operation can be performed in m different ways. Another operation is in n different ways. If at all third operation is also there, fourth operation is also there, we can apply this formula, this principle. Okay, come on, note down. We do some examples on this. Now look at this example. A man has 4 trousers and 3 shirts. In how many ways he can wear different dresses? A dress means a different combination, wearing a pant and a shirt. See, a dress means here, without my knowledge, I said wearing a pant and a shirt, and is coming. So immediately you'll go to fundamental counting principle multiplication now. So in how many ways he can wear trouser? That is first operation. Second operation is wearing a shirt. So first operation is wearing a number of ways of wearing trouser. Number of ways of wearing a trouser. Wearing a trouser. That is his first work. 4 ways. 4 ways. And number of ways of wearing a shirt. 3 ways. And in order to wear a dress, he requires both. So dress means both. Dress means wearing both trouser and shirt. Therefore, by using fundamental principle, by using fundamental counting principle, fundamental counting principle, right? Number of required ways is equal to what we have to do here, and so 4 into 3. So 12 ways are there. Come on, Adam. Okay, look at this example. This is a city. This is another city. This is another city. A person has to travel from A to C. A person has to travel from city A to C via B. He has to touch the city B also. And clearly there are three modes of transport from A to B. And for each mode, again, two choices are there. For flight, two choices, for train, two choices, and for road, three choices are there. And from B to C, only two modes of transport are available, either train or road. So in how many ways he can travel from A to C via B? Now look here, a person can reach C starting from A if two works are done. What is the first work? First work is to travel from A to B. Okay. So number of ways of traveling from A to B. Number of ways of traveling from A to B. Because that is the condition. He has to halt at B. He has to drop at B first of all. Via B, no? Right. So he has to travel from A to B. How many ways are there? Flight, two ways. Okay. He can go through flight. He can go through flight. Here the logic operator, what I have to use? Or and. He can go from A to B through flight or because a person cannot travel through flight and train at a time. Is it not? So either he can choose flight or train or road. So I have to add because here the logical operator or is coming. Or he can choose train. Train also two different ways, two different trains. And road he has three choices. So three. So from A to B, in how many ways he can travel? 7 ways. So first work is finished. First work is traveling from A to B. That can be done in how many ways? 7 ways. Now the second work. Number of ways of traveling from B to C. After first work. After first work. What is first work? Coming from A to B. After that work, okay, traveling from B to C. Now see here how many ways are there. From B, he can go from B to C either by train or road. Again here logical operator or is coming. He can choose this mode of transport or this mode of transport. So this number, how many trains are available? Two trains. Or how many road transports are there for him? Three. So three. So total second work can be done in how many ways? 5 ways. Now the question comes here whether to add this answer and this answer or to multiply. That is important. Now look at this. In order for a person to reach C from A or to travel from A to C, he has to travel from A to B first and he has to travel from B to C. I cannot say he has to travel from A to B or B to C. R means may he travel or not. But in this case, he has to travel. Compulsion. He has to travel from A to B and B to C. So here and operator is coming now. Logically and is coming. So first work into second work we have to do. So here also we are using fundamental counting principle. But at the last case, what we have to do? Multiply. So by using fundamental counting principle. Okay. So number of ways I'm writing here. Number of ways is equal to 7 into 5. 35. I hope you understood. Come on, Redon. At last, write total number of required ways. Okay. Required number of ways, otherwise. I can put it like this. Required number of ways. What is a factorial? A new term here, factorial. In the rest of permutations and combinations, this factorial plays an important role. Actually, factorial is an operator like square root, okay, log, like that. This is also an operator. We say this is an operator. Operator. Square root of 5, we say. 5 is a number. 5 is a real number. And square root is operator. Like this factorial 5, factorial 6, like that. And its definition is factorial is defined for only natural numbers. So I write factorial of a natural number n, factorial of a natural number n is defined as product of, I say a natural number n, okay, a natural number n is defined as product of first n natural numbers, product of first n natural numbers. Suppose if I take 5 factorial, okay, I can write 5 product of first n natural numbers, no? So I write 5 into 4 into 3 into 2 into 1, or 1 into 2 into 3 into 4 into 5. These are nothing but product of first 5 natural numbers. And 2, 3, 6, 4, 24, 5 is 120. Its answer is 120. N factorial means n into n minus 1 into n minus 2 into and so on, 3 into 2 into 1. And one more important result here, that is 0 factorial is 1. This we discuss in combinations. Okay, you have to remember this. In combinations, we'll give its explanation. So if you look at this 5 factorial, 5 into 4 into 3 into 2 into 1, 5 into, this is nothing but product of first 4 natural numbers. Product of first 4 natural numbers. And product of first 4 natural numbers is nothing but 4 factorial by the definition. So I can write 5 factorial as 5 into 4 factorial. So similarly, 7 factorial is there. I can write 7 into 6 factorial. Or I can write 7 into 6 into 5 factorial. Or I can write 7 into 6 into 5 into 4 factorial. Like that, wherever you want to put a break, put a factorial and stop it. Come on, order. Permutations. Permutation is nothing but arrangement. Slowly I'll bring formula for permutation, number of permutations. All right. Number of, here slowly let us find number of permutations formula. A number of ways of arranging, okay, are things from given n different things. So there are n different things. As in my first example, when I gave you introduction of permutations and combinations, I started with taking 4 letters. Is it not? 4 letters A, B, C, D. 4 are different. And among 4, I said to take any 2 and arrange, or any 3 and arrange. Here, n different things are there. I extended that 4 to any number. Okay, n different things are there. out of those n different things, take R things. Out of 10, take 3. Out of 20, take 5 or 6, like that. Like that. So out of n different things, take R things and arrange. Number of arrangement. So how many arrangements are possible? We are going to discuss these things now. For this, in order to understand this well, let me give you some examples. Through examples, we will derive formula. Okay. One example I'll write here. Number of ways of arranging. Number of ways of arranging. I write 3 objects. 3 objects from the given 5 different objects. 5 different objects. Right? Now look here. When 3 objects arrangement is required, we have to make 3 boxes here, draw 3 boxes, and we are going to arrange 5 different objects in these 3 objects, in these 3 boxes, by taking 3 at a time. There are 5 different objects, but take any 3 and arrange them. That is the question. In the first box, in order to fill this first box, how many chances are there for me? 5 different objects are there. No, let us say A, B, C, D, E are 5 different letters. You can take the 5 different objects as 5 different letters otherwise. Okay. And in order to fill this first box, how many choices I have? 5 choices. You can take anything. You can take anyone and put it here. So I have 5 ways. Okay. Right. Now come to the second box. 1 letter I have chosen and kept here. Still, how many are left? 4. So this can be filled in how many ways? 4 ways. 4 ways. Now coming to the third box. Already out of 5, 2 letters have gone. 2 letters are filled here. So how many are left? 3 are left. So this box can be filled in how many ways? 3 ways. You pick up among those 3 one and put it here. We got all ways, no? All possible ways, no? So in order to fill these 3 boxes, this box should be filled, this box should be filled, and this box should be filled. Here, the total 3 boxes must be filled with 5 different objects by taking 3 at a time. Is it not? So we have to fill these 3 boxes. No box is kept empty. So we have to fill it. In how many ways we can fill means? 5, here 4, here 3. Again, here fundamental counting principle comes. In order to fill all the 3 boxes, I have to fill the first box and the second box and the third box. So again, by fundamental principle, by fundamental counting principle, okay, in order to have 3-digit arrangements, okay, number of ways is equal to 5 into first work and means multiply. Second work should be done and third work should be done. So how much? 2060. So how many 3 objects, in how many ways we can arrange 3 objects from the given 5 different objects means 60 arrangements are possible. So 60 permutations are possible. Come on, this better. You can understand this better. If I change the problem like this now, number of I write like this. Number of 3-digit numbers, right? Number of 3-digit numbers formed with the digits formed by using the digits. All right, 1, 2, 3, 4, 5. By choosing 3 of them, how many 3-digit numbers are formed? This is the question. This is same as our previous question. So here also, I want 3-digit number, means keep 3 blank places like this. So we have to use 1, 2, 3, 4, 5 now. How many choices are there to fill this blank? 5 choices. So 5 ways. One number is kept here. One number is kept here. So how many are left? 4 are left. So this blank can be filled in how many ways? 4 ways. Here 5 ways. Here 4 ways. Again, one more number is fixed in this box. 2 numbers gone. How many are left? 3 are left. So this box can be filled in how many ways? 3 ways. 3 ways. Okay. So the number of ways of filling 3 boxes, in order to get a 3-digit number, we have to fill this blank and this blank and this blank. If we don't fill any of the blanks, it is not a 3-digit number. If I don't fill this is not a 2-digit number. If I don't fill this, a 2-digit number will come. We don't get a 3-digit number. So all the boxes must be filled. So this work should happen, this work should happen, and this work should happen. So here also the logic operator AND is playing a role, is it not? So number of ways is equal to number of ways is equal to. You keep in mind which fundamental principle is acting. Okay, and at last you write number of ways. By using fundamental principle only, it is enough if you write number of ways is equal to 5 into 4 into 3. Okay, right. Now what I do is 5 into 4 into 3 now. I'll continue till I get 1. So I have to multiply with 2 and 1. 2 into 1. I divide by 2 into 1. Now both are same. But here I got one formula. Just now, product of first 5 natural numbers is 5 factorial formula is there now. So this is product of first 5 natural numbers, which is nothing but 5 factorial. By 2 into 1 is 2 factorial. But here the 2 important numbers are 5 and 3. From the given 5 digits, I used 3. This 5 is I can understand that this is a given total number of given numbers, given digits, 5. But I don't have 2 here. I have to see only 5 and 3. My important numbers are 5 and 3. I have to write this 2 factorial in terms of important numbers like 5 and 3. I can write this as 5 factorial by 5 minus 3 factorial now. Total number of digits minus used digits factorial. Is it not? So 5 factorial by 5 minus 3 factorial is the answer for this type of problems. If we extend this to the general theory, now look at this. Number of ways of arranging. Now coming to this one. The number of ways of arranging are things from given and different things. From this example, you extend this to this formula. General number of things, n different things and r things. Let us generalize this. Now tell me, 5 is your total number of digits. Here total number of different things are how many? N. So I can write n factorial by, okay, n factorial by total means n minus required. Here 3 digits. No, we require r things. So require. And at last we have to put factorial. I think you understood. So the number of permutations formula can be derived like this. Okay. So number of ways of arranging r things from given and different things is how much? N factorial by n minus r factorial. And later we can denote this by NPR. Let us give a notation for this. Let us give a notation for this expression, for this sentence. Okay. A number of ways of arranging R things from the given n different things is denoted by NPR. And its formula is n factorial by n minus R factorial. P stands for permutations. Arrangement is nothing but permutation. So if you identify the problem as a permutation, you take a P. Arrangement is nothing but a permutation. P. Total number of given things, total number of different given things you keep here. And required number of things you keep it here. This is the notation of number of permutations from here onwards. Okay. So like that we got NPR is equal to n factorial by n minus R factorial. Come on, note down. After writing up to here, after completing up to here, I generalize in general, right? If total number of things is, if total number of different objects, if total number of different objects is n, total number of different objects is n, and required number of objects to arrange, required number of objects to arrange is R, then according to the below problem, formula must be, okay, must be according to given problem is this one. Below problem means, in our previous case, phi is total number of objects. Here total number of objects is n. So n factorial by total minus required. Total minus required factorial. Okay. And after that, now I write. Therefore, the number of arrangements of R objects, number of arrangements, you write it, arrangements of R objects from given n different objects is denoted by NPR. Okay, you write under note. Let us give a notation for number of ways of arranging R objects from given n different objects by NPR. But just now I said how to write number of ways of arrangements of R things from given different n things. Just now we got this. So this is notation. Therefore, this and this must be equal now. Therefore, I can write NPR is nothing but n factorial by n minus R factorial. Right now, you observe this 5 into 4 into 3. 5 into 4 into 3. For that, what I did in my previous problem, 5 into 4 into 3. In order to make it a factorial, I multiplied with 2 into 1 and divided by 2 into 1. Now, the meaning of this one is 5 factorial by 2 factorial. Is it not? 5 factorial by 2 factorial. Again, I wrote this as 5 factorial by 5 minus 3 factorial. Is it not? 5 factorial by and again I denoted this n factorial by n minus R factorial as NPR. So I said this as 5p3. Is it not? This is your R. N factorial by n minus R factorial. So I denoted this by NPR, no? So here n is 5 and R is 3, 5p3. Observe, 5p3 is nothing but product of three consecutive numbers, three consecutive natural numbers, each time reducing by 1, starting from 5. Is it not? 5 into reduce 1, 4 into reduce 1, 3. Like that, starting from 5, how many numbers we have to, how many natural numbers we have to write? 3. Starting from 5, each time reducing 1. Is it not? Now tell me, what should be 7p3? If 5p3 is 5 into 4 into 3, what should be 7p3? Is this not 7 into 6 into 5? Yes, 7p3 is directly 7 into 6 into 5. There is no need to apply formula and write down each case. If you apply formula, what is NPR? NPR is, just now I said, it is n factorial by n minus r factorial, no? So 7 factorial by 7 minus 3 factorial, like that. No need to write like this every time. Directly by using this understanding, you can write 5 into 4 into 3. 7p3 means, don't write like this. Why to waste our time? Directly you can take down it as 7 into 6 into 5. And if you want 25p2, directly 25 into 24. Starting from 25, write any two, write two terms by reducing 1 each time. Similarly, what is 8p4? We have to write 4 terms, 4 consecutive numbers that we understood, starting from 8. So 8, each time reducing 1, I said 7, 6, 5. So that is the meaning of NPR. And finally, what is NPR? What is NPR? How we write other than this? Not like this. What is the actual formula? Like this: n into n minus 1 into n minus 2 into, and so on, n minus r plus 1. N minus r plus 1. 8 minus 4 is how much? 4 plus 1, 5. So your last number is 5. If you look at this, 25 minus 2 is how much? 23. Plus 1 is 24. So what should be NPR? N into n minus 1 into n minus 2. What must be the last term? Your last term must be here. If you observe, 8 minus 4 plus 1, 5. 25 minus 2 plus 1, 24. 7 minus 3, 4 plus 1, 5. So here in NPR, the last number must be n minus r plus 1. So this is also your formula for NPR. NPR can be written like n into n minus 1 into n minus 2 into and so on, n minus r plus 1. Come on, note down.